Yeah, thank you for coming. We've been doing the Birds of a Feather session, Sunil and I, for several years. I checked back, I think it's like 18 years or so. We missed last year, of course, because the conference was canceled, but this was the session actually that was planned for last year. And so I did put the handout that I'm going to go over briefly in the chat. So I think you can download it from there. I'm going to share my screen at the moment, and I'm just going to kind of give an overview of what I do at Parkland, and then also Sunil's added some things too. And then I'll turn it over to Sunil, and then I'll then turn it over to everyone else. One thing you could do during the session is if you can put in the chat any suggestions you have for future sessions, because I plan to keep going with this, have this at other IMACCs in the future, and hopefully, as Mike said, hopefully we'll be back at Allerton. In general, what the topics that we've been covering are things from the calculus sequence, discrete math, things like that, things that typically aren't discussed at sessions at, say, IMACC. IMACC has some, with the intensive math intensive program, but still, you look at the majority of the topics, they're not really calculus level and up. But as you know, several of us do teach calculus. We're pretty fortunate at Parkland because with the University of Illinois so close by in Champaign, we were able to offer calculus 1, 2, and 3 and differential equations, fall, spring, and summer. So we were able to, have a steady teaching of those courses. Okay, so at Parkland, we have a 4-credit-hour Calculus 2 class, and Power Series is part of that. I use the TID9 calculator for the class. My colleagues often use the TID4 Plus. We're using Rogowski, Adams, and Franzos as their calculus book. We used to use Swolkowski for many, many years, but unfortunately that's been discontinued. So we're using this book. This is the best we could find. It was still being continued. Solis and Hill is actually still out there too. I have that in the references. I like that book. That's still available. The 2007 edition, I believe. But some book companies are going away from older books, especially since the authors have passed away. And then I also have listed what the courses at Harper and the topics there, and Sunil will talk a little bit more about that. So when I teach the sequence of topics that I cover in the series part is I start with sequences, and then what I do is I talk about Taylor polynomials. And the reason I do that is because I told the students that what we're going to do next is the goal is to represent a function as a function as a polynomial, say a transcendental function. And so I say that's our goal for the rest of the material we're going to cover in this segment. And usually it's about, say, 6 weeks of the course. Then I go into infinite series and talk about telescoping series, geometric series, and also the nth term test for divergence. And notice I stress nth term test for divergence. I don't just say nth term test, because unfortunately, a lot of students get confused with nth term test and what we did in sequences and think if the limit exists, then that means the series converges. Now I said, no, the limit can't be 0. So, if the limit isn't 0, then the series diverges or doesn't exist. So I keep describing it as a divergence test, not anything else. Then we go to the integral test, and then the basic comparison test. Then I do the ratio test. Now, some faculty do the root test. I don't do the root test. I don't do a limit comparison test myself because I ask them to do all the, I find problems that are limit comparison tests, but then I tell them they have to use the basic comparison test for it. Sometimes it's a little bit more challenging to set up the inequalities. And then with alternating series, it varies from textbook to textbook, but I found the best strategy is to discuss absolute convergence first, because some textbooks just go right to the alternating series test and then say, oh, it's conditionally convergent, but they don't understand that the reason it's conditionally convergent is it didn't converge absolutely. So I require them to do the absolute convergence test first, and then use the alternating series test if it doesn't converge absolutely, and then it could be conditionally convergent. And then, of course, the remainder theorem. Then I go to Taylor series, and I use Lagrange from the remainder, and then also talk about some approximations. And then I end with power series, and then, of course, tie it back to Taylor series. One thing that's interesting to note when I use the T89 is that I tell the students that they could actually do more problems with the integral test now, because you don't actually have to know how to evaluate the integral. Just the 89 can do it for you. So it opens the door to some more possible uses of the integral test with the CIS calculator. Applications that I discuss, my background actually is physics. So I talk about that in physics 1 and 3, we use the small angle approximation, which is basically a Taylor series. So, you know, the sine of x is approximately x and the tangent of x is approximately x for small angles. We use this in for the simple pendulum problem. And also we use this for interference in physics 3, when you talk about light interference. Another application is differential equations, of course, power series. And that's where the ratio test comes into play a lot, because you'll use that later on. And then also in quantum mechanics. And in fact, one of my friends is a physicist too. And he always, when we discuss, whenever I bring up Taylor series, he says, well, if you're a physicist, you have to have Taylor series ingrained in your bones. Okay. And then also we talked briefly about Fourier series, of course, which is going to come up into differential equations. At Parkland, we don't really cover Fourier series per se, but we made a point of getting a textbook that did Fourier series, because when they transfer the University of Illinois, they're expected to know some Fourier series or know how to do it, especially if they're in mechanical or electrical engineering. And then these are the proofs that I do, and then also Sunil added to this list too. The geometric series test, of course, that's also, you see that in college algebra. The proof of the nth term test for divergence, the integral test, the P-series test, which relies on the integral test, the basic comparison test, limit comparison test, ratio test, root test, and the alternating series test. And as I mentioned, I prove absolute convergence first. And then power series test, what I just mean by that is that it allows you to talk about the 3 possibilities when you have a power series for the interval of convergence, or what the radius of convergence, things like that. And then I've given some references here. As I mentioned, Solison Hills is very good, and Lighthold is very good too. Unfortunately, Lighthold's been discontinued, but that's got, especially the 7th edition, has a good, it's very good theoretically, but it also has a lot of graphics calculator applications where you use a Taylor series approximations or the approximations for alternating series. So it's a pretty good reference for that. And although, as I said, it's been discontinued by the publisher, and I think what it was is Lighthold, before he passed away, he said that he didn't want it to ever be issued again. So if you get a hold of a copy of that, I'd recommend it. Another thing that Sunil and I talked about is when we do the power series, or Taylor series, power series, and we want to look at the interval convergence, as you know, you use the ratio test. But then how do you test the endpoints? Well, if you want to test the endpoints, we need to go back to some of these other tests, because L equals 1 at the endpoints. And so the limits equal to 1 at the endpoints. And so we have to do these other tests. So sometimes students say, well, why are we doing the other tests if the ratio test is so important? Well, I say we have to, the ratio test doesn't always work for these. So let me turn it over to Sunil.
Okay, in addition to what he mentioned, in the Parkland Calculus 2 course, we do integration by parts. We have a 5 credit hour course. So we do additional topics, integration by parts, trigonometric integrals, integrals involving trigonometric substitutions, rational integrals and partial fractions, improper integrals, algebra and calculus of hyperbolic functions, conic sections, transformation of conic sections, including rotations and parametric curves. And I forgot to add the implicit integration here. I'm sorry, numeric integration, which is a required topic for IAI. So we have to have numeric integration here. So I would like to hear what others do for numerical integration.
Well, I certainly do trapezoidal rule, and that's relatively easy to motivate geometrically. And then go to Simpson, show how much better that works. Use a spreadsheet to get very good approximations. I don't attempt to prove Simpson. Maybe I should, but that's what I've been doing lately.
And of course, when you do the power series and Taylor series, you can approximate integrals that way too, right?
Of course.
I mean, do you use some kind of a program, you know, like numerical integration? So you're doing like some programming?
Yes, I do write programs on the graphing calculator. I mean, that's easy because that's in your hands, you know, so I usually go through that. But I think the spreadsheet is the tool that they really need. And those are relatively easy to design. And then that way, rather than using a canned program, if you make the students write the spreadsheet, they at least get a feel for what's happening with the algorithm. And it's a little bit nice, at least with Simpson, to actually draw some of those parabolas, right? Because you're using a quadratic approximation. So I do some visual stuff there in terms of, okay, you have those 3 points. Let's go ahead and fit the parabola. Let's see it. So I think that's kind of a nice application as well, or nice use.
I think we should open it to everybody now, right?
Yes, yeah. So please, everybody, if you want to make comments about what you're doing at your school, or also, of course, down the road, we can talk about, I didn't mention it, but students always have difficulty with series. So what are some things that you do to try to have more students succeed with that topic? That's another thing to look at.
This is Amy. I don't have any great advice. Actually, I had a question because it turns out Calc 2 was my favorite course when I started, and now it's my least favorite after a number of years of teaching it and feeling like it was not getting better for me. And the biggest issue for me is keeping the students engaged through the long series, you know, all 10 tests that they're trying to learn and things like that. And I kind of, you know, I tell them, you're not going to get a huge payoff in this course, maybe. You know, I can, you know, we'll get to the point where, yes, now we can integrate or find some representative of the antiderivative sign of x squared. But, you know, that's sort of the big payoff we get to is talking a little bit about that. I mean, I feel like I'm being honest with them in some ways, that this is is kind of a big detour. It doesn't feel like calculus for quite a while. But that, you know, that's the difficulty I have is keeping them engaged through that very long slog. But I don't know.
I liked Omar's suggestion of doing the Taylor series first.
Yeah.
And what that does is that kind of tells the students that these things are kind of the DNA of these transcendental functions that we study so much. You know, what are they really? What does sine x really represent? I mean, they've never thought about that before. So it's almost getting into a philosophical discussion with them. You know, I found that to be helpful. And another tool that I use is I pull out the graphing calculator and I add up the first 1,000 or 10,000 terms. And let's see, does it look like it's going to converge or not? Let's guess. What do you think? Well, is that enough for us to prove that? Now let's go ahead and try to identify what it's going to be. But Amy, I'm with you. I mean, why they feel they need to learn a dozen different strategies to determine if a series converges, I could understand why students might argue that that's not necessarily a good use of your time. And it's not something we do in Calc 1 or in Calc 3. We do a little bit in differential equations. So it is a bit of an outlier. But again, it's my favorite part of the sequence because it's the most mathematical, right? So, I mean, just be passionate about it and try to have them see it. But it's a challenge, no doubt.
Yeah, I read part of a book, I can't remember who the author was, who talked about sort of this, you know, how to create sine x, you know, by taking a little bit of x, a little bit of x squared, how much of x cubed should we take, kind of thing. And so, you know, it's sort of, you know, a story I can at least tell and sort of present it that way. But yeah.
And how that's related to the ratio of the opposite side of a triangle to its hypotenuse, I mean, that's mind blowing.
Mm-hmm.
And then why that works only in the radian world and not in the degree world, that's also a good discussion you can have.
Okay.
So if folks have an inclination towards mathematics, I think this is where you turn them on. If they're engineers and they just want the tools, then I think you got to go to Omar's approach with the Taylor. Say, we need to study what this function is. We have most integrals we can't do, they're impossible. So we need numerical schemes. Here is one technique to get at one of those numerical schemes.
And especially if they're engineers, they're going to be seeing this again, power series and differential equations. So I want to make sure they've got a solid foundation with that, because that way when they go to differential equation, it isn't, oh, what's this? What are we doing?
Absolutely.
And then there's also a discussion of how many tests you want to do. I mean, I remember years ago, Jim Tresco and I talked, and Jim said, why aren't we doing RABS test? You know, I mean, there's so many tests out there. How many do you want to do? What's going to be the most helpful for these students, especially if they're saying engineering majors? You know, the ratio test they better know. You know.
Absolutely.
Yeah, I tell them, you know, this is the top 10, you know, this, and then we rank them, you know, I say, okay, I'm on the top 10. What do you think? You know, which one would you start with? So it does sort of help them figure out, well, if it looks like this, I'm going to do that kind of thing, and which ones they use most often, or I ask them to use most often, and things like that. Although Omar was also glad to see the textbook we use does call it the nth term divergence test now. Our old book called it the nth term test, and so now at least they're calling it the nth term divergence test.
Well, if I could extend on that, should you call it the alternating series convergence test?
I
Because
do. Well, I mentioned at least that's what it's used for, just convergence.
Yeah, you don't really use the alternating series test to prove something diverges. I mean, if the absolute values don't converge, then it diverges by the nth term divergence test. So I think that might be another side of that coin.
Now, when I have them use the alternating series remainder, I require that they show that it passes the alternating series test.
Oh, okay. Right.
And not all textbooks do that. And even in their little solution manuals, they just say, oh, it's an alternating series. We're just going to use the remainder theorem. So.
Well, Omar, let me ask you about the telescoping series then.
Mm-hmm.
Because I believe you need to show that the partial sums shrink to zero, that the difference goes to zero. I believe you've got to create that sequence of partial sums. However, I've seen textbooks where they just kind of cross out the terms as they go and say, boom, what's left in the beginning is what we have. So, I mean, I think there's a certain amount of formality we need to have there that I think is often lacking in a lot of textbooks. Just a thought.
But on the other hand, some of the telescoping series that you see initially, if you just want to test the convergence of them, you don't have to find the sum, right? So later on. They might be just a regular P series or basic comparison test type thing, you know. And that's another thing you have to stress to them. We're not always going to be able to find the sum, you know, after you do the first first part of introduction into the series.
Omar, what are your thoughts on the current AP calculus system on the BC course? Do you feel that's doing an adequate job in preparing students for Calc 3 and DiffyQ?
I don't think so. In fact, I think, like, for example, University of Illinois, if somebody comes in with a AP credit for BC, they say, well, you should probably take some this additional course that goes into applications and series. You know, because I think they view it as kind of weak on series.
I've been pretty critical of the BC exam for years. I am not bragging. I am saying this because neither of my girls are math majors, but both of them got 5s on the BC exam. And I don't think they learned very much. So I looked at it pretty closely. I think they routinized it, you know, in terms of computation, right? Primarily computation, very few applications, very little theory. I just didn't think it was much of a course, you know, so, and you don't need to get much more than about 50 or 60% of the points on that thing to get a 5.
Right.
You know, so, because so many students know very little that there's so much grade inflation there. So, but I realize we have to accept it. At the 2-year colleges, we can't be like the U of I. If someone comes in with a 4 or a 5 on the BC, we've got to move them on to 3rd semester calculus. But that's been a concern of mine.
And actually, currently, the way things are, it's been difficult these past couple semesters because, as you probably know, even with the AB exam, they shortened it. They shortened
yeah.
the content.
Pandemic.
Yeah, because of
Yeah.
the pandemic. So the students are coming in and maybe not even knowing exponentials and logs into Calc 2.
Wow.
And that could be very challenging.
I haven't seen that. I just taught Calc 1 this year, so I haven't seen that. Next year, I'll get to experience that, I guess. Wow.
And also in my experience, this is more anecdotal. It depends on how they learned. You know, sometimes in high school when they have the AP class, they'll go beyond just the test.
Well, of
You know,
course.
Yeah.
they'll teach more than just the AP test. So if the student has a better, deeper understanding of calculus than just how do you pass the AP test, they might be successful even if they get a 5, you know, on the AP because they know more than the AP.
Of course. Yeah, that's an excellent point. But a lot of suburban high schools have parents who demand their kids get high scores on those exams,
I
and they
see.
keep their jobs based on the scores on the exams. So there's a lot of motivation to teach to the test that we have to recognize is out there.
Now, in our course, we teach conic sections, and then do the rotations, you know, transformations, etc. So where do you teach those things? Not in, if not in calculus 2, where else? Because you need that in calculus 3 when you talk about quadric surfaces. When you say there are only 6 non-degenerating quadric surfaces, to prove that you can use the rotations of the conics, if you have seen it.
Well, you can look at the gray-haired guys here. You know, Sunil's hair, if he had it, would be gray. Omar's is gray, and mine is certainly gray. And at the start of our careers, people took a course called analytic geometry. It was in the taught in the universities. It existed. And then right around the time that I finished school, it went away and it became analytic geometry and calculus. That's what most schools called it. Now, you don't even see analytic geometry in the title for these courses anymore. So yes, calc reform has been a good thing. And I was involved in that way back in 1987. I think our new version of calculus has some good things, but there is no doubt in my mind that analytic geometry has been sacrificed. So I don't see much of it in Calc 2. Yes, we talk about how you draw graphs of various things. So we talk about that a little bit. But the kind of analysis that should be done is certainly not done. And in the pre-calculus even, I think that's even being de-emphasized. You're seeing less on the conic sections there too. And rotated conics, Sunil, I'm willing to bet you may be the only person in Illinois doing rotated conics.
It's in our course. I mean, it's in our syllabus.
Okay, but maybe your school. I just, you know, talking around the country, I don't find a lot of folks who are still doing that. It's a really nice application, especially for people who are going into things like graphic design, digital animation. Because if you can build the theory up and you can see how you can kind of do that change in space, that's a real nice application. But I just think it's one of those things that, given the amount of material that is now in the curriculum, that has been greatly de-emphasized. We can talk about whether it should be. I would like a good pre-calc course. I would like, heck, I'm not quite old enough for this, but I have books on my shelves on solid geometry. Okay. So that was done a generation before Omar and I were in school. You know, that I picked it off the shelf a couple times a year and I'm fascinated by it, but it just has gone away. So, you know, 20 years from now, when the three of us are, you know, all sitting up with our feet somewhere, I'm not sure what else is going to go away, but we have some work to do if we're going to bring the conics back, no doubt about it. But I agree with you. For quadric surfaces, students need to have good, solid understanding of how those conic sections work, no doubt about it.
Yeah, and you're right. In a lot of the textbooks, they used to have separate sections for parabolas, ellipses, hyperbolas, but a lot of the newer calculus books just condense it all into one section and maybe have a few examples. Now what I do is if I have enough time at the end of calculus 2, I will do rotation of conics and I'll show them the matrix form. And I'll say, this is a rotation matrix. And this is what you can set up as an array in a computer program. And then that's how you can rotate, objects. And then there's also translation of those objects and things for computer graphics. And that usually catches their interest because they say, oh, I'm interested in that.
Exactly. And I do that in linear algebra too. That's a real
Yeah.
nice application there to build it there. But yeah, like I said, I would be happy if they could, do the analysis. Can you graph a hyperbola? Can you tell me what the focus is? Can you tell me where the vertices are? Do you have some idea, how does the transverse axis? So that when we get to Calc 3, I want them to visualize that quadratic surface, they can do it. But here's the question. Given these things, right? Given these things, given Desmos, given the good 3D applications that are out there now, how much graphing are we going to be doing in a generation? Or are we going to offload all of it to the technology? Because I always go back to the square root algorithm, right? So some of us learned that in school and no one teaches it anymore. So, over time, things do change, so I don't know. I love the analysis of 3D figures. I love the quadratic surface stuff, but I don't know. I don't know if 20 years from now, that'll still be a major emphasis, especially, that the big change that is going to come in advanced math at the 2-year colleges is they're going to want to have more statistics, right? More applications in statistics, maybe even using sophisticated databases. Like I've mentioned the spreadsheets. These are the tools that students are using. So I think we're going to be under a lot of pressure to change our curricula to include more of that kind of material.
Omar, I'll just jump in here for a second on that discussion.
Yeah.
And really upset Bob here for a moment.
Feel free. You've never done it before, Kevin. You can start now.
Okay, go ahead, Kevin.
The curriculum committee is currently working on revisions for college algebra and trig, and conic sections is likely going to be moved to a further topics. And that's actually coming from a lot of the ISMAA folks who have a 3-credit hour college algebra, and they said all they do is circles and parabolas.
Wow.
And call that conic sections.
That's great. Now I really feel old, Omar. What can I say? I knew it was coming.
Yeah, it's just all the time. They're all the time. Barely at 2 and 2.
Oh gosh.
Do you use computer algebra systems like Mathematica or Maple?
I was a fan of Jerry Ewell and Horacio Porta's Calculus and Mathematica program they had down at the U of I in the 90s. I thought they did some really good things. However, most of the students I knew that took that program couldn't stand it. They felt there wasn't enough guidance. So that's why I don't think it's really survived. It hasn't thrived. Is it a useful tool? Oh, absolutely. Absolutely. And the fact that Wolfram Alpha is free and anybody can use it is great, and it's terrible. I mean, I'm trying to write exams for my calculus class this semester, and if I know students can just type it into Wolfram Alpha and get a completely worked out solution, that's going to be difficult. So yeah, it's a tool, it's a tool like anything, and there's times to use it, and there's times that you want to avoid it. But yeah, how is that going to change the curriculum going forward? That is a great question, Sunil. I don't know. I'm curious what our colleagues have to say.
Well, it could go like what we did with, remember when people were adverse to having a calculator, in other words, you need to know how to multiply 10 times a number or something. That's reasonable. But if it's, a 5-digit number times a 6-digit number, I'm not going to do that by hand, things like that. So where do you reach for technology?
If I can shake my fist about something, is the old man saying, "Get off my lawn." Wow. Doing a lot of one-on-one tutoring sessions on Zoom this year. And the number of students in pre-calculus and calculus who cannot multiply fractions is staggering. And I guess they have never really had to do it, right? I mean, they've relied on calculators all the way along. So, and I'm not usually a person that's a Luddite on technology. I tend to be a person that embraces it early, but wow. I mean, people in calculus that are trying to cross multiply to multiply fractions. That happened yesterday. So we need to be at the table. We need to be having these conversations in terms of what the curriculum is going to be. And listening to Kevin, it sounds like conics are really on the way out. Well, okay. I'm not happy about that, but if that's going to happen, that's going to happen. But then what's going to take its place? We don't want to have a reduced curriculum. We don't want to have a lessened curriculum. We want to maybe a more focused one, but I'm just curious the direction it's going to go.
Now, are conics
I think,
oh, good.
I think the reason college algebra is winding up in that further topics is there's finally a recognition that college algebra is still doing far too much for far too many audiences. And the thought was there's actually among community colleges a push to have two college algebras, one that leads to statistics, your business majors, and a different one that leads towards the traditional calculus sequence, and put the emphasis in each of those where it belongs.
Gotcha.
That is what we have at Harper. We have a college algebra course, which is really not a college algebra course, which is designed for those people who are going into statistics and business calculus. And then we have a real pre-calculus course, which leads to calculus 1 and beyond.
And
So we tell our students that you take calculus, pre-calculus, only if you are planning to take calculus. Otherwise, don't take the class.
and then if you're outside of Illinois, college algebra is even different, right, Bob?
Yeah. Oh man.
If you go to a MATIC and people are talking college algebra, it's not the same as what we're offering in Illinois.
No, and for those who don't know, I've been in Florida for the last couple of years. Intermediate algebra is a college level class in Florida. So that's one thing. The course that everybody takes in Florida is college algebra. Everybody takes it. So that goes against Linda Sun's idea. So, if you don't know that story, she insisted, gosh, many years ago, that let's get students off the college algebra pre-calculus track and get them on a quantitative literacy track. And I applauded her for that. And I think MAA and IMACC are kind of going in that direction now again. They're recognizing that you can't have everybody in pre-calculus. But I cannot tell you how many students I have this semester in pre-calculus who are telling me this is the last class they're going to take. So nationally, people want to get an AA degree. They need 2 math classes. They're taking college algebra and pre-calculus, which I just think is crazy. So, I applaud Linda Sun's, for trying to separate those two. And maybe what Sunil's school is doing is right. I may not call that other class college algebra though, Sunil.
No, it's called pre-calculus.
Yeah.
Or the other class.
It's called,
it's called college algebra.
Oh, I'm sorry. Okay, you have like pre-business calculus and pre-regular calculus.
No. We have a
Not
college algebra that is not a college algebra course for the business calculus and, but it's called college algebra, unfortunately. But then the real college algebra and trig class is the pre-calculus class.
I gotcha. Okay. Yeah.
I may have missed this earlier, but just to take it back to infinite series here for a moment.
Sure.
I'm curious where everybody puts that topic in the actual Calc 2 timeline. Is it last? Is it in the middle?
Yeah, I can mention for Parkland, what I do is I start off with method of integration, your integration by parts and go through partial fractions. Then I do work and fluid force and center of mass. And then I do L'Hopital's rule, improper integrals, and then we start series. And then we do series for about 6 weeks, and then we end with conic sections, parametric equations, and polar coordinates.
That is exactly we do at Harper too.
That's been my experience most of my career at the various schools I've been at. At College of DuPage, we also did intro to vectors at the end.
Oh,
So we got through dot product and cross product. That was crazy.
I
That's
see.
what we did.
And Bob, is that a 4-hour class?
No, 5, everything.
Oh,
was
okay,
fine.
yeah, I'm talking about a 4-hour class for us, so yeah.
The College of DuPage, it was 555,
I see.
which was nice.
Okay.
We have several instructors who have moved infinite series to the last topic in Calculus 2 because they were concerned about how little parametric equations and polar experience students were getting coming into Calc 3. Unfortunately, I think what that means is infinite series winds up being the topic that gets curtailed if you run out of time.
I think I've seen some schools that push the series all the way to Calc 3. But that's an option that some folks are doing. Certainly on the quarter system, I taught on that for years. And Calc 1 was derivatives, Calc 2 was integrals, Calc 3 was series, Calc 4 was vectors. So that kind of had a nice way to sort of cut things out. But yeah, I think what Omar said is the traditional thing: techniques of integration, applications of integration, series, and then parametrics and polars at the end. I think that's the typical way that most textbooks are organized.
Our book
Speaking
actually
of textbooks,
reverses applications and integration techniques, which is bizarre.
Huh. Yeah. Yeah, I guess I have seen that, haven't I? So you're doing work and you're doing disk method with very easy functions to integrate. Yeah, that is crazy. I have seen that.
I think that's a lot of textbooks have it in the, yeah, you're right. They could be in the calculus 1 part, right? But a lot of us push work and center mass toward Calc 2, right?
That's what I'm used to. Can I ask some people that are here if any of you have gone to OER and how much success you've had with it? Because we're using a book right now that's not bad. I'll look up its name if anybody wants to know. And then we're using WebAssign with an OER book. There's a big push down in Florida to try to save students money. So that's, you know, it is what it is. I don't think the students read the book much anyway. So I would assume current versions of things like Stewart or Larson are probably $200 plus.
Right.
So I'm just curious if anyone has gone in that, anyone else has gone in that direction.
I would like to know what it is you are using, if you care to share it sometime.
I'm sure before we're done, I'll pull it up on my page here.
Okay,
yeah, it's not bad. When I was at UIC, I was there for 3 years. We negotiated a very good price with one of the publishers on a textbook because we bought so many. We were able to get a year version of calculus together with my math lab for less than $100 for 2 semesters. But that was really good negotiations that the person had.
So at Harper, we use an OER book. If you want to buy the book, it's $30, the OER book. Otherwise, online is free. But then we work with.
Do you know what the author is, Sunil?
I don't use that book. So, so what I did was I talked to the Wiley and said that book is $30. You cannot sell Anton for $200. So they came down on the price for $46. So it's comparable.
Wow.
I'm using Anton for $46 for my.
Wow.
I'm using Calculus by OpenStax, which I think is out of
I
Rice.
think that's what we used to.
Out of Rice University. It's not great. If I wrote it, it'd be better.
No.
It'd be a lot better. But you know, and there's not 8,000 exercises in every section. You know how most of these big books, these giant books have 8,000 homework problems. This has many fewer, but a lot of the questions are pretty good. It's not real high end on theory. You know, they kind of short sell that a little bit, but yeah, I mean, versus $200, I can give them more theory in my videos and my lessons. I'm cool with that, and I tend to write my own homework questions anyway, so I don't mind using the OER.
Yeah, talk to the publishers, they come down very fast.
Well, that's good to know.
Wow.
That's great to know.
Mm-hmm.
This might be interesting. Our administrators just told us 2 days ago they're going to use COVID funds to purchase lots of textbooks for all of our courses, and they have announced our students for fall free textbook rental for everything.
Well, my dean told me today at my school in Florida, which is about It's about the size of COD, maybe a little bit smaller, but not much, 80% the size of COD, that we expect to get $33 million in government funds.
Wow. Yeah. I sort of have been, I've been grappling with engineering majors. I think they need to keep their calculus book and their physics book, and they're going to be, they're not going to buy it, or they're going to feel pressured to not buy it. Parents are going to know that we're offering these books free to use. And so I'm a little bummed by that. But I kind of like this negotiation idea. I may do it myself, or maybe see if our bookstore person might try to negotiate a price. So anyway, thanks for that info.
And there's cheaper versions of WebAssign and My Math Lab out there now. There are other companies who are putting digital homework systems together. So I encourage you to look at those. So if you do want to go to OER, you can save your students quite a bit of money. And certain schools are demanding that all the books go OER. Most of the for-profit colleges in the country either write their own stuff or adopt OER. So my guess is we're going to see a bigger push in that area as well. So Omar, when are you writing your book? You've got time, right?
That's a lot of work. Calculus book would be a lot of work.
All those good physics problems. Come on, Omar, you're a leader in that area. You've got to do it for us. Sunil can be your co-author, right? Sunil, you're retiring next year. You can sit on the beach in Sri Lanka.
We have like a Calculus 3 textbook now, because I have to teach it online. So I told them, you don't have to write notes. I'll give you the notes. So
there you go.
So I have a textbook now. I have to add the questions, homework questions.
That's great.
That I used Anton, so they use the Anton only for homework.
I see.
Yeah.
Well, that's basically what I do. I write my notes and I post them online. So they essentially have a book and then they do their homework in the textbook. That's what I've always done.
And I also have embedded videos. So it's like a video notes.
See.
Why don't you put them on YouTube for the whole world, Sunil?
I think it's in YouTube. All the videos are in YouTube.
Good. Yeah, mine are on YouTube as well. If you do a search for my name, you can see 8,000 videos. If you need to go to sleep, if you have insomnia, put on one of my, basic algebra videos. You'll be asleep in no time.
Yeah.
You see your computer. Can I just ask the people who are on who we haven't heard from yet, what you're doing about writing exams for students to take in a distance learning environment? What type of strategies are you using, given the fact that Wolfram Alpha is out there and Chegg is out there? How can we write sheet proof? Or, Sunil gave us his idea, write really tough multiple choice questions that the students will have to think about conceptually. I like that a lot, Sunil.
Yeah. So
other ideas?
What I do is I have timed exams. So the multiple choice question, 3 questions, multiple choice, 15 minutes. So they have to answer it within 15 minutes, otherwise they get 0.
That's pretty
and
good,
then
Sunil.
I have a 1-hour exam. I post the exam paper on the web, so they can download it, and I don't check who's writing it or anything, but it's timed. So within an hour, they have to submit, otherwise they get a 0 too.
Well, how many of them have the internet going out at exactly 58 minutes after they get that paper? Then all of a sudden the internet's out, or their phone stopped working, or the electricity went out.
Once in a while, somebody would say that.
Once in a while.
Once in a while.
Okay.
But most of the people are cheating. So they are basically sending, like, you can see that people are working together, even though I said this is individual, this is an individual exam.
Of course.
So, so there's nothing much you can do with that.
So here's what I've done. I signed up for a free account on GradeScope, and I show the students exactly how they need to position their computer so I can see their whole body, their whole desktop, and their phone. I can see it. And then they can log into their GradeScope account and see the exam, and they sit there and work it on paper. So I'm on Zoom, they're logged into GradeScope, taking their tests. And then the nice thing about it, it will take photographs from their camera. They don't have to upload PDFs. And it was really smooth. I was thrilled that I took my entire Christmas break to learn how to use it. It was a pretty big learning curve. And I felt pretty good about that. Mm-hmm.
I've used GradeScope for a couple of years. It is a terrific program, but they don't have to upload PDFs. This is interesting.
Correct. They do not. They can. It'll take PDFs or photographs. It'll just take it. I don't think I set up anything special to allow it. Okay. I think I can require them to, I can just tell them, look, I'm not going to grade it if it's a photograph, because some of them would upload a photograph that was a little too dark. But I got that fixed pretty quickly. My problem with not being before GradeScope, I could only accept PDFs, or they'd put photographs in the body of an email, and it was just a nightmare trying to get things printed where I could. It was terrible. That's what I had to do, with the sudden remote thing, because I hadn't been doing it online. But yeah, the GradeScope is here. Here's the other thing you should all know in case you haven't tried it. You get on there and all the students' names. You open up the thing, you click on grade assignment, and you get a stylus or, a Wacom tablet. And I can grade those things as fast as I can when I have their stack of paper in front of me. And by grade, I mean by hand, annotate. And as soon as you tap on a button, it saves that grade for the student, moves on to the next student. Anyway, I'm a big fan, and it's a free account.
Yeah,
in terms of
the first person college to use it, you can get a free account for sure. That's what I found.
Yes, first 5. Is that what you said? Yeah, it's 5.
First few, yeah.
Yeah. Okay, I just didn't hear you. Uh-huh.
In terms of writing exams, I've found, I always feel like the exam on sequences and series is the easiest to not worry about cheating on, only because I always require all my students to write out arguments with complete sentences describing how they're reaching their conclusion. I don't know how many people necessarily always do that. I remember going through Calc 2 and it was just every problem was multiple choice, converges or diverges, for like pretty much everything. So asking them to kind of write out their thought process, it changes a lot, because when you go to something like Wolfram or a lot of these other places, that's all they're going to tell you is just, oh, this series converges by the root test, or something. And so they might get a sense of what test to start looking at. But if they can't explain kind of how it works and walk through the steps, then that's not really what I'm looking for. So that's been a big help. Do a lot of people typically ask students to write things out, like complete sentences, kind of moving more towards like taking the calculus sequence as a way to potentially help students learn to do some of those things that we know they all don't do, like read their textbook or read theorems all the way through, as opposed to just jumping to like the line that has like a formula on it. I find that there's a lot of, that's one of the big advantages of the series section, just outside at least of the story of Calc 2, is that you can start to almost, it's like a prep for a intro to proof class, in that you can kind of, and calculus does the same thing, but you can kind of slowly start getting them to be a little bit more careful in how they're articulating their thought process, and getting them to kind of think with you, read carefully with you, and try to help them master those skills, so when they get to later courses, they can be a lot more successful. But I don't know if a lot of other people do that.
Well, you better, because if you just ask them if it converges or diverges, that's very easy to an answer on Wolfram.
Absolutely.
I'm with you, or on a calculator, frankly, to get a decent approximation. I'm with you. I look at all of those problems as proofs, and I figured this is an opportunity to teach them how to at least write a pseudo-proof in mathematics.
I don't require full sentences, but I spend a lot of time saying there better be an introduction where you tell me what test you're using, a body where you tell me you're actually using that test correctly, and a conclusion, just like writing an English essay.
Yep. Excellent.
For me, I have them write out all of their work for all of the stuff, no matter whether it's series or not. And they have to show it. I've not used the one program you mentioned before, but our school has been using HonorLock for that sort of thing. And then they post their work in PDF form in our LMS. And then I grade through that, and I don't require sentences because I don't really want to grade based on their language skills. But but they have to have it, as they said. I mean, I like the way the other person put it, and having an intro and a body and a conclusion. But there is the problem state. You have to tell me what test you're using. You have to show me the use of that test, and then you have to tell me what the result is. So.
Okay, well, thank you for your time. I guess our session goes, what, 50 minutes? Is that right?
Yes.
But also, if you do want to make some suggestions on future sessions of the Birds of a Feather, as I said, I'm planning to continue this. You can send me an email. Thank you for your time. And Sunil, do you want to say something?
No.
Okay. And we're going to, I'm recording this, so once I get the close out, then I'll post the recording. I'll send it to Michael, and then he'll post it later.
All right.
So we
Thank
have-
you.
Thanks so much.
You.
Okay, thank you.
Thanks.
I'm going to stop.